The Earth's shape has been a subject of curiosity and study for centuries. While the planet appears flat in our day-to-day experiences, extensive scientific research and empirical evidence have demonstrated that the Earth is an oblate spheroid, slightly flattened at the poles and bulging at the equator. This shape is a consequence of the Earth's gravitational forces and its rotation. We will delve into the scientific basis for the roundness of the Earth and explore the intriguing thought experiments of what the world might be like if it were a triangular or cubic shape. The round Earth, scientific basis. Observational evidence. Since ancient times, sailors, explorers, and astronomers have noticed phenomena that point to the Earth's curvature. As ships sail away from the coast, they appear to sink bottom first due to the Earth's curvature. Similarly, during lunar eclipses, the Earth casts a round shadow on the Moon's surface. These observations align with the concept of a spherical Earth. Circumnavigation. One of the most compelling pieces of evidence for the Earth's roundness is the ability to circumnavigate the globe. Sailors and aviators can travel in a straight line in one direction and eventually return to their starting point. This phenomenon would be impossible on a flat surface, as the consistent direction and distance of travel wouldn't coincide with a flat world. Gravity and horizon. The Earth's gravitational force pulls objects toward its center, naturally forming a spherical shape. This force acts equally in all directions, which is why objects on the surface of the Earth are drawn toward the center. The curvature of the horizon as we move away from our viewpoint is also a result of the Earth's spherical shape. Satellite imagery. Satellite images and photographs taken from space provide clear visual evidence of the Earth's spherical shape. These images are consistent with our understanding of how celestial bodies form due to gravitational forces. The curvature of the Earth's surface can be seen in these images, further confirming its roundness. Astronomical observations. The way the Earth casts a round shadow on the Moon during a lunar eclipse and the changing positions of stars as you move north or south are consistent with the Earth's spherical shape. Different constellations become visible as you travel to different latitudes, which wouldn't be the case on a flat Earth. Hypothetical scenarios. Triangular and cubic Earth. Triangle Earth. Imagine a world where the Earth takes the shape of a giant equilateral triangle. In such a scenario, the distribution of land and water would be drastically different from what we currently observe. The angles of the triangle's corners would define the continents and oceans, leading to unique weather patterns and ecosystems. Challenges and disruptions. The triangle's corners would pose significant challenges for habitation due to their sharp angles. The distribution of sunlight and darkness would result in extreme temperature variations. Weather patterns would be unusual, driven by the geometry of the land masses. Gravity and geology. The gravitational forces on a triangular Earth would behave differently. The three corners would have varying gravitational strengths, affecting the behavior of tides, ocean currents, and atmospheric circulation. Curvature and horizon. The concept of horizon would be redefined on a triangle Earth, as the shape lacks the smooth curvature of a sphere. The view from one corner to another would differ significantly from the view along the edges. Cube Earth. Consider a world where the Earth transforms into a cubic shape. This cubic Earth would have 6 faces, each representing a distinct environment and set of challenges. Environmental diversity. Each face of the cube would experience different sunlight exposure, leading to varying climates and ecosystems. The corners of the cube would likely be inhospitable due to their sharp angles and limited habitable space. Tides and ocean currents. The behavior of tides and ocean currents would be complex, influenced by the shape and orientation of the faces. The interactions between different faces could lead to unusual patterns of water movement. Astronomical implications. The cube's corners and edges would impact the visibility of celestial bodies. The changing positions of stars and constellations would be unpredictable and unique to each face. Structural challenges. A cubic Earth would present structural challenges, as the sharp angles and edges could cause geological instability and disruption of natural processes. Therefore, spherical shape of the Earth is supported by extensive scientific evidence and observations spanning centuries. It is a result of the interplay between gravitational forces and the planet's rotation. While the notion of a triangular or cubic Earth is intriguing, these scenarios would lead to drastic disruptions of natural processes and defy our current understanding of physics and geography. The spherical shape is not only visually evident from space but also explains a multitude of natural phenomena and allows for stable gravitational forces and consistent environmental conditions across the globe.